if you've watched the other video, you've seen a couple sample problems using the pH equation. I'm going to add a couple more equations that might give you some shortcuts. You can also find pOH. Again, this is kind of the opposite of pH in terms of values. But the equation is very similar. It's going to be the -1 times the log, but instead of the concentration of H plus, you will use the concentration of OH minus, which can be very helpful if you are starting out with a concentration of OH minus and they want you to find the pH. You could actually use this in conjunction with this next equation. pH plus pOH is always equal to 14. As I cannot write, I was going to say 7. Okay, it's always equal to 14. So these are two other equations that you can use. So now you have a total of 4 equations. Remember, we have our pH equation, and you have your Kw, your ion product constant equation. So we have a total of 4 equations that you can use and manipulate to solve different problems. So all I'm going to do now is walk you through some problems. Again, we saw some simple ones, but I'll do a couple more simple ones just because. Like if they say the H plus concentration is 0.0010 molar, they could ask you what is the pH. They could even ask you what is the OH minus concentration. What I would do first for pH is you could plug it right into the equation, but I'm going to take a little shortcut. This is 1, 2, 3, so this is 1.0 times 10 to the -3 molar. This is a 1, that's why I did that, and that's a 3. So I know my pH is 3. Now here's another shortcut. Using the Kw, remember Kw is 1.0 times 10 to the -14. That means these two must add up to 17, or add up to 14, sorry. So my equation would look like this, and I've got 1.0 times 10 to the -3. What would my next one be? 10 to what? Well, -3 and what will give you -14? That would be -11. So that's 1.0 times 10 to the -11. Now I know that was kind of quick, and it does take a little bit of thought to do it that way. If not, take 1.0 times 10 to the -14 and divide by 1.0 times 10 to the -3, and you will get the -11. You know, these shortcuts, again, typically only work with coefficients of 1, so keep that in mind. So most of the time we're not going to have a coefficient of 1, and you're going to have to use the equation. So if you want to, just practice the equations and don't worry about the shortcuts. All right, so this is where the only tricky thing about it is you've really got to watch what they're giving you. So my first question says, what is the pH? Again, these are just coming from your book. If you have a solution and it has the OH minus here, and it gives us concentration of 4.0 times 10 to the -11 molar. Okay. This is our hydroxide ion concentration. It cannot be plugged into the pH equation. It can be plugged into the pOH equation, and you could find the concentration of OH minus, or it can be plugged into the Kw equation, and then that answer can be plugged into the pH equation. Either way, you're going to have to use 2 equations. I think what I'm going to do is use pOH and then use this equation, just to take a little bit of a shortcut. Okay, so I'm going to say I don't have H, I have OH, so this is what I'm going to use. 4.0 times 10 to the -11. Get out the handy dandy calculator. Remember, you're using your log button. 4e to the -11, and then hit my log button. And then times it by -1. So my pOH is 10.11 9.4. Okay? But they wanted pH, so I'm going to use this equation up here. I know that pH is pH plus POH, which is 10.4, must equal 14. Therefore, pH is equal to 14 minus 10.4. So that's going to give me 3.6. So I have a pH of 3.6. Now, do we have to do it that way? Again, no. You can switch it around. Let me show you using the same equation, so using the same idea. What is the pH if my OH minus is, and let me pick a new one, we'll get a different value. If my OH is 4.3 times 10 to the negative fifth molar. Now I'm going to use the kW instead this time. So kW is equal to the concentration of H plus times by the concentration of OH minus. So this is 1.0 times 10 to the negative 14th. I don't know my H plus concentration, but my OH minus concentration is 4.3 times 10 to the negative fifth. Okay, so that's all plugged in. Sorry, I didn't realize I was off screen. Okay, next, solve for x. So 4.3 times 10 to the negative fifth. 4.3 times 10 to the negative fifth. So again, put that into your calculator. Make sure you're using your exponent button. So one special button, e to the negative 14th divided by 4.3, e to the negative 5. Okay, and that's telling me my x is 2.35581,395 times 10 to the negative 10. So it's giving me all of that on my paper. Okay, this, remember, is the concentration of H plus. So when I go to find pH, negative log of H plus, this number goes in here. Well, that's on my calculator. So all I'm going to do is hit log, and then see the 9.633 times that by negative 1, and that gives me a pH of 9.63. So you have two ways that you can do it. You could have found the POH and then use pH plus POH equals 14, or you can go KW and then the pH equation. So with those four equations, you can solve anything as long as you've got your calculator. If you remember the shortcuts, you can do the shortcuts, but again, you don't have to. All right, I'm going to do just a couple more variations. One of my questions says, what is the H plus concentration if my pH is 7.30? Okay, once again, this is where you have to do the inverse. So we've got pH is equal to negative 1 log concentration of H plus. So this is 7.30 negative 1 log of x. Remember, this has to come over here. So this is going to give me a positive 7.30 log of x. To get this, I have to do my inverse. So I'm hitting my second button. Some of you will not have a second button, or some of you'll hit second log first, and you'll get like 10. It'll show you 10 to some power. Okay, just type in negative 7.3. So 10, negative 7.30. Because remember, the shortcut said that this would be 1.0 times 10 to the negative 7.3 molar. That would be my concentration, but you can't have exponents with a decimal. So you have to get rid of that, and your calculator will do that for you. If you don't have a log button, you could look for the 10 to the x button and plug in negative 7.3. But make sure you make it negative. Oops. Because it was positive at first. Sorry. That was positive. This is negative. I'm rushing. Do not rush. All right, so 7.3 divided by a -1 gives me the -7.3. Inverse log on my calculator. It doesn't give me enough digits, so I have to put it into scientific notation, and that's what it gives me. And that is, since you probably can't see that very well, it tells me that x is 5.01 times 10 to the -8. And don't forget that would be molar. So that's what that would give you. Again, you might have to play around a little bit with your calculator, so make sure you're looking at this as you are doing those. Always watch for what they're giving you. Are they giving you OH minus, or are they giving you H plus? Okay, that's going to be the biggest thing. I'm going to look for a couple more practice problems that we can do together just to make sure. Again, a lot of it depends on if you have your calculator. Okay, so I have another one that says, what is the hydroxide concentration? What is the hydroxide concentration if your pH is 9.00? Again, I can do this in the shortcut manner. I don't know if you can, so I'm going to go the long way. I'm going to start with pH plus pOH is equal to 14. So I have 9 here. I don't know what this is, and this is 14. So I know that X is 5. So pOH is equal to 5. Okay. From there, I'm going to use pOH is equal to the negative log of the concentration of OH minus. So I'm using inverse log. So this is 5, -1 log of X. So this would be -5 is equal to the log of X. And then hit my second log, and it's going to tell me 1.0 times 10 to the -5 molar. Okay. You could have used kW on this one if you wanted to. You could have said using pH of 9. You could have used pH is equal to the negative log of the concentration of H plus. And then this would have been 9, and that would have been -1 times the log of X. Then -9 is equal to the log of X. That means that you're going to go inverse log for -9. 1.0 times 10 to the -9 molar. But again, this is for H plus. And then I could use kW is equal to the concentration of H plus times by the concentration of OH minus, where kW is 1.0 times 10 to the -14th. This is 1.0 times 10 to the -9. So what is my OH minus concentration? Take this, divide it by that, and you're going to get 1.0 times 10 to the -5th molar. Okay. So you have a lot of options. I like this one up here better. It seemed like it went a little bit quicker. Okay, but that's going to be up to you, how you want to solve that. Okay. Again, you have options. If you have your calculator, just make sure you do that. Maybe I know I talked very quickly through these. Maybe do some pauses, take a look at it, and slowly try these problems before you get the answer.